So first, what is Hec-Hms? Hec-Hms stands for Hydrologic Engineering Center's Hydraulic Modeling System. Hec-Hms is designed to simulate the precipitation/runoff processes of dendritic watershed systems. It is also designed to be applicable in a wide range of geographic areas for solving a broad range of problems. This includes large river basin, water supply, and flood hydrology to small urban or natural watershed runoff. So this is the hydrologic elements that we used. Basin. Basin is any area of land where precipitation collects and drains off into a common outlet, such as into a river, bay, or other body of water. Sub-basin. The sub-basin element is used to represent the physical watershed. Reach. The reach element is used to convey stream flow downstream in the basin model. And junction. The junction element is used to combine stream flow from hydrologic elements located upstream of the junction element. So this is the profile of Tarlac. Tarlac is located in the central part of Luzon. It has 17 municipalities and 1 city grouped into 3 congressional districts. Tarlac province has 511 barangays distributed within the 17 municipalities and Lone City. Tarlac covers a total land area of 3,053.45 square kilometers or 305,345 hectares. Approximately 75% of the province are plains, while the rest is hilly to slightly mountainous. The Tarlac River is a river in central Luzon, covering a drainage area of 1,900 square kilometers, traversing the provinces of Tarlac and Pangasinan. The Tarlac River is very important for agriculture, human livelihood, and irrigation. The Tarlac River is located between the northern latitude of 15 degrees 9 minutes 29.16 seconds north and eastern latitude of 120 degrees 20 minutes 52.8 seconds east. Tarlac's climate is classified as tropical. In winter, there is much less rainfall than in summer. The average annual temperature is 27.2 degrees Celsius in Tarlac. Precipitation is the lowest in January, with an average of 6 millimeters. Most precipitation falls in August, with an average of 432 millimeters. At an average temperature of 29 degrees Celsius, May is the hottest month of the year. In January, the average temperature is 25.4 degrees Celsius. It is the lowest average temperature of the whole year. Between the driest and wettest months, the difference in precipitation is 426 millimeters. The average temperatures vary during the year by 3.6 degrees Celsius. The profile of Tarlac River. Tarlac River is dammed at Barangay Tibag in Tarlac City, where its water is used for irrigation and distributed to the northern and central regions of Tarlac. The rest of the river is now a bed of sand. Background of the study. The province of Tarlac is one of the commonly flooded areas due to its geographical characteristics. The province is surrounded by high mountains along its eastern and western outskirts, but predominantly the province is a vast flat area. The river originates around the vicinity of Mount Pinatubo and empties itself into the Agno River at Poponto Swamp, located between the boundaries of Tarlac and Pangasinan. It was formerly the site of traditional balsa or bamboo raft riding. until the river was heavily silted by sticky lahar or mud flow brought by the eruption of Mount Pinatubo on June 15, 1991, filling the river with over 10 feet of lahar. Its main tributary is the Odonel River in Santa Lucia, Capas, Tarlac. These are the methods that we used. First, we developed the basin model. Second, we determined the precipitation or rainfall areal average. Third, we parameterized the basin model. Fourth, we add stream flow and precipitation gauge information. Fifth, we create a meteorologic model. Sixth, we create and run a simulation. Seventh, we calibrate the model and evaluate model performance. And last, we create an uncertainty analysis and evaluate results. This is the topographic map of Tarlac. We use topographic maps because these are detailed and accurate graphic representations of features that appear on the Earth's surface can be seen here. These features include roads, buildings, urban development, railways, airports, names of places and geographic features, administrative boundaries, state and international borders. As you can see, this is the elevation map of Tarlac, and the given elevations for the subbasins are Kamiling 20 meters, Paniki 21 meters, Herona 31 meters, Mayantok 48 meters, Capas 41 meters, and Bamban 58 meters. This is the model of Tarlac River, plotted using the Hec-Hms software. As you can see, we have 6 subbasins, namely Kamiling, Mayantok, Bamban, Capas, Herona, and Paniki. We also have 2 junctions and an outlet, and 2 reach. Bamban and Capas are connected on junction 1, while Mayantok and Herona are connected on junction 2, and Kamiling and Paniki are connected to the outlet. Sample computations. CN stands for curve number, H elevation, and L is the distance. And these are the formulas that we used. For the storage, S is equal to 1000 divided by Cn minus 10. For average slope, gamma is equal to H divided by L. And for lag times, TL is equal to L raised to 0.8 multiplied by S plus 1 raised to 0.7 divided by 560 gamma raised to 0.5. The given for Kamiling are Cn is equal to 60, H is equal to 20 meters, L is equal to 13,300.67 meters. The storage for Kamiling is 6.13. The average slope is 1.5029 times 10 raised to negative 3, and the lag times 362.90 minutes. For Paniki, Cn is equal to 69, H is equal to 21 meters, and L is equal to 6,554.86 meters. The storage for Paniki is 4.49. The average slope is 3.20 times 10 raised to negative 3, and the lag times 117.54 minutes. For Herona, Cn is equal to 69, H is equal to 31 meters, and L is equal to 3,371.58 meters. The storage for Herona is 4.49. The average slope is 9.195 times 10 raised to negative 3, and the lag times 40.74 minutes. For Capas, Cn is equal to 70, H is equal to 41 meters, and L is equal to 15,887.44 meters. The storage for Kapas is 4.286. The average slope is 2.58 times 10 raised to negative 3, and the lag times is 258.84 minutes. For Mayantok, Cn is equal to 59, H is equal to 48 meters, and L is equal to 39,884.37 meters. The storage for Mayantok is 6.95. The average slope is 1.20 times 10 raised to negative 3, and the lag times is 1053.15 minutes. And for Bamban, the given are Cn is equal to 63, H is equal to 58 meters, and L is equal to 19,796.54 meters. The storage for Bamban is 5.87. The average slope is 2.93 times 10 raised to negative 3, and the lag times is 347.96 minutes. After inputting the data in the Hec-Hms, these are the computed results. As you seen in the screen, this is the precipitation graph of Kamiling. The graph in the upper portion is the HYDROLOGY. It indicates all the precipitation in the month of August. The red bars indicates the loss in the precipitation in the month of August. In August 1, it interprets that there are many water that lost due to the slow velocity of rainfall. But in the following days, because of the consecutive rainfall, the losses lessen, and also because of the fast velocity of water. Followed by the precipitation data. This is the precipitation data in Kamiling that happened from August 2 to September 1. Recorded in this data are all daily precipitation, losses which is the precipitation that infiltrate, the excess, and the water that ran off to the basin. It is recorded here that from August 3 to September 1, there are many runoff than the losses. The summary of results for sub-basin Kamiling. It indicates here the peak discharge, which is 99.8 cubic meter per seconds, and it happened in August 4, 2018. The total precipitation is 802.10 millimeter, less the loss that infiltrate into the ground, which is 140.09 millimeter. So the excess is 662.01 millimeter, and the total runoff that flow into the basin, which is Tarlac River, is 660.53 millimeter. The precipitation graph of Mayantok. In August 1, it shows that there are many losses than the water that ran off, but in the following days, because of consecutive rainfall and the fast velocity, the runoff are higher than the losses. And the precipitation data that happened from August 2 to September 1. It is recorded in the data all daily precipitation, losses which is the precipitation that infiltrate, the excess, and the water that ran off to the basin. It is recorded here that from August 3 to September 1, there are many runoff than the losses. The summary of results for sub-basin Mayantok. It indicates here the peak discharge, which is 292.9 cubic meter per seconds. It happened in August 13, 2018. The total precipitation is 1,533.70 millimeter, less the loss that infiltrate into the ground, which is 170.41 millimeter. So the excess is 1,363.29 millimeter, and the total runoff that flow into the basin, which is the Tarlac River, is 1,359.49 millimeter. the precipitation graph of Bamban. It also shows that in August 1, there are many losses than the water that run off. But in the following days, because of consecutive rainfall and the fast velocity, the runoff are higher than the losses. While the precipitation data shows that in August 1, there are many losses or infiltrating water than the runoff. But from August 3 to September 1, there are many runoff than the losses. The summary of results for Sub-Basin Bamban. It indicates here the peak discharge, which is 244.4 cubic millimeter per seconds. It also happened in August 13, 2018. The total precipitation is 1,527.36 millimeter, less the loss that infiltrate into the ground, which is 165.50 millimeter. So the excess is 1,361.86 millimeter, and the total runoff that flow into the basin, which is Tarlac River, is 1,352.46 millimeter. Precipitation graph of Capas also shows that in August 1, there are many losses than the water that ran off. But in the following days, because of consecutive rainfall and the fast velocity, the runoff are higher than the losses. And the precipitation data that is recorded from August 3 to September 1 shows that there are many runoff than the losses. The summary of results for Sub-Basin Capas. It indicates here the peak discharge, which is 371 cubic meter per seconds. It also happened in August 13, 2018. The total precipitation is 739.80 millimeter, less the loss that infiltrate into the ground, which is 100.02 millimeter. So the excess is 639.78 millimeter, and the total runoff that flow into the basin, which is Tarlac River, is 639.63 millimeter. The precipitation graph of Paniki also shows that in August 1, there are many losses than the water that ran off. But in the following days, because of consecutive rainfall and the fast velocity, the runoff are higher than the losses. While the precipitation data shows that on August 1, there are many losses or infiltrating water than the runoff, but from August 3 to September 1, there are many runoff than the losses. The summary of results for Sub-Basin Paniki. It indicates here the peak discharge, which is 95.3 cubic meter per seconds. It happened in August 8, 2018. The total precipitation is 1,313.60 millimeter, less the loss that infiltrate into the ground, which is 110.05 millimeter. So the excess is 1,203.55 millimeter, and the total runoff that flow into the basin, which is Tarlac River, is 1,202.35 millimeter. And lastly, the precipitation graph of Herona also shows that in August 1, there are many losses than the water that ran off, but in the following days, because of consecutive rainfall and the fast velocity, the runoff are higher than the losses. And the precipitation data shows that in August 1, there are many losses or infiltrating water than the runoff, but also from August 3 to September 1, there are many runoff than the losses. And the summary of results for Sub-Basin Herona. It indicates here the peak discharge, which is 46.2 cubic meter per seconds. It also happened in August 8, 2018. The total precipitation is 1,335.60 millimeter, less the loss that infiltrate into the ground, which is 110.17 millimeter. So the excess is 1,225.43 millimeter, and the total runoff that flow into the basin, which is the Tarlac River, is 1,225.43 millimeter. The graph shows the precipitation of Kamiling, Paniki, and also the reach to where the other sub-basin and other two junctions are connected. It also shows here the total precipitation of the reach 2 plus the Kamiling and Paniki. And because of these graphs, even though without the data, you can simply determine the peak discharge and also when it happened. The data shows the daily inflow of the reach 2, Paniki and Kamiling, and their total that becomes an outflow. The summary of results for junction outlet. This junction is the last junction, that's why we called it outlet. It indicates here the peak discharge or outflow, which is 1046.3 cubic meter per second, happened on August 4, 2018. And it also indicates the volume of water, which is 1025.64 millimeter. The graph shows the precipitation of Capas and Bamban. Capas and Bamban is the first source of flow of water into the Tarlac River. It also shows the total precipitation of Capas and Bamban. The data shows the daily inflow of the Capas and Bamban and their total that becomes an outflow. And next, the summary of results for Junction 1. This is the first junction because this is the start of the Tarlac River. It indicates here the peak discharge or outflow, which is 589.4 cubic meter per seconds, happened on August 4, 2018. It also indicates here the volume of water, which is 902.45 millimeter. The graph shows the precipitation of Mayantok, Herona, and Reach 1. It also shows the total precipitation of Mayantok and Herona, and also the outflow of the sum of the Capas and Bamban, which is the Reach 1. This data shows the daily inflow of the Mayantok and Herona and their total that becomes an outflow. And the summary of results for Junction 2. It indicates the peak discharge or outflow, which is 890.5 cubic meter per seconds, happened also on August 4, 2018. It also indicates the volume of water, which is 1054.23 millimeter. These are the precipitation data and graph for Reach 1. And this is the summary of results. It indicates here that the peak discharge or outflow, which is 589.4 cubic meter per seconds, happened on August 4, 2018. It also indicates here that the volume of water, which is 902.45 millimeter. And these are the precipitation data and graph for Reach 2. And then these are the results. The result of the Reach 2 indicates that the peak discharge or outflow is 890.5 cubic meter per seconds, happened also on August 4, 2018. It also indicates here the volume of water, which is 1054.23 millimeter. And finally, the summary of results for Tarlac watershed modeling. And this graph shows the precipitation in Tarlac in the month of August. The x-axis is the sub-basin, while the y-axis is the precipitation. The two bars in each sub-basins are the total precipitation and the direct runoff. It shows here that Mayantok has the highest number of precipitation and Capas has the lowest. And because of this, Mayantok has the highest direct runoff and the Capas has the lowest. And lastly, the appendix. And these are our references. Thank you for your watching.